All right, IVAISL2. Today we're going to learn, continue our work with derivatives and talk about maximums and minimums of functions. So before we get to that, I realize there's some calculator skills that you guys probably need for this course. So we're going to consider this function right here, x plus 2 over x minus 1. We're going to find the gradients of the curve at x equals 2 and x equals 3 using a GDC. The reason we're using a GDC is that you guys don't know how to take the derivative of this. So some people might think that you just do the power rule for like the individual spots, but it doesn't work like that because there's an x in the numerator and the denominator. There is actually a rule to be able to do it by hand, but we're not going to expect you guys to do it in this course. So we're going to reach for the graphing calculator. First step is I want you to put x plus 2 over x minus 1 into y1 in your calculator. So you're going to hit that top left button, the y equals, and then do a parentheses and do x plus 2, close parentheses, divided by x minus 1, parentheses, and then graph it up. Now, when you graph it, you're going to see something like this. Now, to be able to find the gradients of the curve, which the gradients are just the slopes, and you would normally use the derivative, you're going to hit second calc. So here we go. And then find the dy dx button, which you may have seen this button before, and been like, oh, I know that notation now. It's a derivative. So if you hit the dy dx button, it's going to ask you to trace along it. But instead of tracing along it, you can actually just put in the x values you're looking for. So if I literally just hit the button 2, it'll say x is equal to 2, and then you hit enter. And then it tells me it's negative 3.000003, which is close enough to negative 3. So that means that the gradient is negative 3 at x is equal to 2. Then if you do the same thing again, you go second calc dy dx and then punch in a positive 3, you get negative 0.75. So feel free to use this magic dy dx button to check answers and things. I think I will expect you guys to do certain things by hand, but it will be very explicit in the instructions about when I want you to use the calculator and when I don't. Oh, just a quick, what we were actually finding. That means that at 2 on the graph, which I think with my scale would be right here, there's a tangent with a slope of negative 3. So that means that the slope equals negative 3 at that point where this is 2. Now, today we're going to start talking about stationary points. There's 3 kinds of stationary points. First of all, where the stationary points are is where the derivative is equal to 0. It's the x value it's the coordinate where the derivative is equal to 0. So that coordinate is when you put a c into the derivative, you get a 0 out of it, and then f of c is the y value on the original function. Now, you guys, this is where gradients switch from positive to negative or negative to positive or vice versa, or sometimes they don't switch at all. So let's take a look right here at this first one here. If you're riding your surfboard on the curve, that means you're going uphill to the left of this point, and then you're going downhill to the right of this point. That makes this, first of all, a stationary point, but it's a maximum. I guess it's a local maximum is what they call it. It might not be the entire maximum of the entire curve, but it's a local maximum. So when it switches from positive slope to negative slope, that's a local maximum. Then down here on the second point, if it switches from negative to positive, this is a local minimum. And then if it doesn't switch at all, like this with this point, like if this is going uphill, 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 so this is positive, but then afterwards it's still going uphill, so this is another positive. This is neither a local maximum or a local minimum. You can find these spots by setting the derivative equal to 0. All right, let's do some examples. So consider that curve right there, 3x cubed plus 2x squared minus 4x plus 2. First, find dy dx. Well, dy dx is just taking the derivative. So using the power rule, the old pop and drop, we get 9x squared plus 4x minus 4. Then it says on the same set of axes, sketch y and its derivative. So for this part, use your GDC. Like really, you can use your graphing calculator for anything unless I say don't use your graphing calculator. So I'm going to do my best to really sketch this accurately. I think the first curve looks like a little bit of a roller coaster that goes like up here, and then it comes down and it crosses, and then it goes back up, something like that. So this is y. Now, dy dx is a parabola, and when you graph it, I think you get something like this. Ugh, this little, here, we'll try again. Ugh, sorry, one more time. It's because I have to illustrate a relationship between these things here. There we go. So this is dy dx. Now, it says solve dy dx equal to 0. If I set the derivative equal to 0, there are certain quadratics that I will expect you guys to solve, but I don't think this is a nice one. I think when you like try to do the quadratic formula or factor or any of those tricks, it doesn't work out nicely. So here's what I want you guys to do. Use 0 function on calc. What I mean by this is just graph 9x squared plus 4x minus 4, and then you go second back to the calc menu and use the 0 function. Now the 0 function, you're gonna have to tell it like to the left of a spot. So like if you're gonna, what we're trying to do is find these two spots on the derivative where it's equal to 0. You have to tell it to start looking, you know, on the right of this spot, and it'll put a little arrow, and then tell it to stop looking on the left. Sorry, start looking on the left and stop looking on the right. And then you have to do a guess, and then the guess you just have to put somewhere near it. But then when you hit enter, it should tell you that that first intersection is negative 0.925. And then the second one is 0.481. So these are the values that make the derivative 0. Now, I literally just found these spots right here. But in relation to the original curve, these are the x values of the turning points. Notice, or the stationary points, these are the spots that would have a flat tangent. Like the tangents would be totally flat to the curve. So we know the x value of this is negative 0.925 comma something, and then this one is 0.481, comma something. So part D says, what does part C tell you about the original curve? This tells you these are the x values of the stationary points of the original curve, which you can see here that I tried to make these line up, that where the derivative crosses the x-axis are the same as the turning points on the original curve. The turning points of this guy right here. If the domain of y is -2 to +2, find the actual maximum and minimum. What you have to do with this part is check these values in the original function. So what that means is we're going to take this and then replace the x with -2 and with +2. So we'll say y is equal to 3 times -2 cubed plus 2 -2 squared minus 4 times -2 plus 2. And I think that is 26. But then you also have to check the other one. 3 times 2 cubed plus 2 times -2. No, not negative, positive. +2 squared minus 4 times +2 plus 2. And then I think this one is -6. Oh, I got them flopped. Sorry. I think the top one is -6 and this is 26. So sometimes these are called the global min and max. Global minimum and global maximum. Last problem. Consider this curve where x is not equal 0. That's just so you're not dividing by 0 in the denominator. Find dy dx. To be able to find dy dx, we first have to do a little rewrite of the original problem where you have to take this guy and kick it back upstairs and make it a negative exponent. Then dy dx is going to be just a 1, which is the coefficient of that x right there. But then the -1 needs to come out in front and then drop down 1. So we do minus x to the -2. And then if I clean that up, this is 1 minus 1 over x squared. So that is the derivative. Now, sketch the curve. This is using your graphing calculator. I believe when you graph this, you get something like this. So this is y. Now it says find the coordinates of any local minimums, maximums, or minimums. You could use a feature on your calculator if you go to the calculate menu called minimum or maximum. And I'll try to post a different YouTube video that shows you how to find those easily. It's like you select minimum or maximum and then it tells you like which curve you're looking for and then like where the start point is, where the stop point is, and then you tell it like look to the left on this side and the right on this side, and then you make a guess and then it will tell you what this point is right here. But I wanted to show you guys how you can actually find this using algebra. Because those minimums and maximums are where the derivative is going to be equal to 0, because you get a flat horizontal tangent, you can set the derivative equal to 0 and try to solve this. If I subtract 1 from both sides, we get -1 equals -1 over x squared. Divide both sides by a negative, we get 1 equals 1 over x squared. Multiply both sides by x squared, and you get x squared is equal to 1. then square root both sides, and you get, not how, plus or minus 1. So that means that this coordinate right here is 1 comma something, and this coordinate is negative 1 comma something. Now, I don't know what the y values are. So what you have to do is plug these into the OG equation to figure out what the y values are of those coordinates. When you do that, you should get negative 2 and positive 2. So 1, 2 is a local minimum, and negative 1, negative 2 is a local maximum. Then the last part says find the gradients of 2 points close to but on either side of the minimum. So the minimum is right here, and that's at 1. So if you plug in, like let's say a 0.5 into the derivative, that means dy dx is equal to 1 minus 1 over 0.5 squared, which is negative 3 when you put in your calculator. Then if you pick another point, like on the other side, let's do 1.5, just on the right, and you do 1 minus 1.5 squared. This is not a nice number. It's like 0.556. The most important thing to realize is that this is a negative number and this is a positive number. Explain why this shows that the point found is a local minimum. Well, local minimums are where the slopes change from negative to positive. So what we found is that just on to the left of that, the slopes were on a downward trend, and then just to the right of that, the slopes were on an upward trend. So whenever it switches from down to up, that means that it's a valley, it's a minimum. All right, you guys, I apologize for the long video. Don't worry, we're going to kind of practice things next class.